Alright guys, this is unit trigonometry. Our objective is to go over radians, sectors, and arcs. Oh my! So radians. Radians are a different way of measuring an angle, other than degrees. And so for 1 radian, it's the same length as the radius of a circle. 2 radians is 2 radiuses of a circle. Like the arc length is that. Okay, so if you were to go all the way around, it would be the circumference, which is 2 pi r. And every time you just take away the r, you get 1 radian, 2 radians, and then this one would be 2 pi r radian, or 2 pi radians. So for a whole circle, you get 2 pi radians. Okay, so we can write that out as a conversion. So for every 2 pi, you get 360 degrees. And I take that, that's weird. I take that a little bit further and I get the simplest conversion, which is just pi equals 180 degrees. So that is the main conversion that I will be using. You can use 2 pi equals 360, but for me it's just easier to simplify and get pi equals 180 degrees. So pi radians equals 180 degrees. If we wanted to convert these degrees into radians, you want degrees to go on the bottom, so 180 degrees to go on bottom, and then pi goes on top because that's what you're trying to get to. So like the whole reason why you do that is because then the degrees cancels, and so 30 divided by 180 equals 1/6 times pi equals pi over a 6. 90 degrees, same thing, multiply by pi over 180, and the degrees cancel out, and you get pi over 2. So there are two formulas that are in your booklet for testing. One is for the arc length. If you don't want to have to go fumbling through your booklet in order to get to it, it's just, I memorize it as LERT, so length of sector equals radius theta, and so that equation is L equals radius theta times theta. Area of a sector, I haven't come up with a good acronym for that, or a really good way of memorizing that, except the area of a circle is pi r squared, and so you substitute out pi with 1/2 theta. So yeah, that is the area of a sector formula. But again, these are in your formula booklet, so if you just look under the topic circular functions in your formula booklet, you'll find these two formulas. And I wrote them here just like they are in your booklet, so that way you get accustomed to seeing them that way. Anyway, so this example, in the circle arc, AB equals 7.86 centimeters, and I went ahead and drew the diagram, but typically you'll just be given this example. So the arc length equals 7.86 and the area equals 23.58. Find the central angle theta and the radius r. So we want to find r and the theta. With this you have 2 unknowns, but you also have 2 equations. So the arc length 7.86 is equivalent to the radius times the theta, and your area 23.58 equals 1/2 theta r squared. So I'm just gonna do by substitution. So you have 7.86 equals theta r. I'm going to solve for r by dividing by, or I'm going to solve for theta. So divide by r. And the reason why I wanted to solve for theta is because when I substitute in theta, this square is going to go away. and you'll see what I mean. So theta equals 7.86 divided by r. Substitute that into the second equation, so 23.58 equals 1/2. Theta we said equals, in this equation, 7.86 divided by r times r squared. And as you can see, because I have an r in the denominator and an r in the numerator, you get 23.58 equals 1/2, and then these cancel, so times 7.86 times r. And I'm going to solve for r, so we get r equals 2 times 23.58 over 7.86, which equals 6. So we found r, now we just need to find theta. And so I plug that into 7.86 equals 6 times theta, divide by 6. Theta is going to equal 1.31. Awesome. So this is how you can use the area of a circle, or area of a sector, and arc length of a sector, or arc length of a sector. Two the same thing, different way of saying it. Anyway, okay, short video.